Hey friends, I want to thank our sponsor, Raygun. Are you struggling to replicate the bugs and performance issues that your customers are reporting? Plug Raygun into your web and mobile applications right now and diagnose problems in minutes rather than hours. Kiss goodbye having to dig through log files and relying on frustrated users to report issues. Make your software development life so much easier using Raygun's error, crash, and performance monitoring tools. Every software team can create flawless software experiences for their customers with Raygun. Try it free today at raygun.com. That's RAYGUN.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Dr. Alex Constantin. She's a director of data science at Tandem Diabetes Care and a fellow type 1 diabetic. How are you?
Hi, I'm very well, thank you. How are you?
I'm getting there. I feel like between us, we've got like 50 plus years of diabetes experience here. This is pretty cool. Although I've been living it, you've been living it, but then you also have a background in data science. So you get to manage your own disease with an expertise that understands the data that you're creating.
Yep, I think some of my diabetes knowledge definitely started personal and with a lot of training, like most people. But now
Mm-hmm.
I combine what I find in the data with those hypotheses that I developed from personal experience, and just look at what the data tells us.
Mm-hmm. Now, when I became a type 1 diabetic in the 90s, I would prick my finger and I would wait about a minute until a little piece of gauze turned blue, and then a little light sensor would look at the color of blue, and then the darker the blue, the more sugar I had in my blood, and that was pretty fancy for the 90s. And then I would write that into an Excel sheet or on a piece of paper, and I would log that. I think I would check my blood sugar maybe 5 or 10 times a day, and everyone thought that I was checking so much. Why would you check your blood sugar so much? How did you start out?
Well, so I was diagnosed when I was 7, and I grew up in Romania. So it's still early 90s, but the technology hadn't quite all gotten to Romania at that point. So
Mm.
I was admitted to the hospital when I was diagnosed, and I spent about a month there to get my insulin dosing quite right. And at that time, no one was using test strips as the common way of testing blood sugar.
Mm-hmm.
So I was getting blood drawn intravenously to test how my blood sugar was before and after meals and really adjust those doses.
Mm.
So it was very lab driven. It all had to happen in the hospital.
Mm-hmm.
And then a few years in, we got test strips and were able to use those at home, and it really changed things.
That's a really good point. And even now in 2020, a lot of the technology still isn't accessible to people for geographical reasons, whether it be far flung places far away from where the labs are, or whether it be cost or medical, depending on the medical industry within that country. There are things that I can do and you can do now here that may not be available back home.
Right. We have all the best technology right now, systems that are able to adjust insulin doses in real time based on continuous glucose monitoring, but that's not really readily accessible to a lot of people.
Mm-hmm.
And that's something that hopefully will change over time, and more people will benefit from this technology.
Indeed, there's definitely people still who are doing what they call MDI, right? Multiple daily injections. They prick their fingers and they take injections the same way that I did 30 plus years ago. So it would be nice to make those things available to them. But the one thing that they all have in common, and they always have had in common, is they're producing data. It feels like it's a thing about diabetes that's quite unique. We create a lot of data about our bodies and always have.
Right. Diabetes is certainly one of the most data driven conditions that I know about, between the continuous glucose monitoring, which is both used as outcomes, but also as inputs to all the decisions you're making,
Mm-hmm.
and all the factors that can affect blood glucose levels. There's really a lot of data that you could have, and a lot of data that is hidden in the background, affects blood glucose levels, but we can't quite measure or really do data science about.
Yeah. One of the things that I've always found frustrating about diabetes is you can tell me what my blood sugar is this moment, but I don't know if I'm doing a good job until 20 years from now when I don't go blind or when I don't have a cardiac issue or I don't lose my kidneys. So there's all this data I'm producing every day, all the time for the last 20 or 30 years. But by the time I find out if it worked or not, it's too late.
Yeah, well, there are some outcomes that are immediate and some that are longer term. I think diabetes is a balancing act.
Hmm.
You want to provide insulin because your body is no longer producing it, but getting the dose just right is very difficult.
Mm-hmm.
And if you give too much, then you have hypoglycemia, which can have immediate consequences. So you might feel a little bit shaky or sweaty, but if it's really extreme and it's not treated, you
Mm-hmm.
could have seizures or lose consciousness, end up in the hospital, or even die. So that's very acute, and preventing that is a big focus with diabetes management. But then if you don't give enough insulin and if you have chronic hyperglycemia, then you're at risk of these microvascular complications, which will show up years later, like you said. So
Mm.
it's a control engineering problem. You're
Mm-hmm.
trying to keep things in this very tight, narrow range and account for all the factors that might influence glucose levels and
Mm-hmm.
also predict them. And unlike other control engineering problems, humans have been the ones who were manually solving the control problems. And now with the introduction of automated insulin delivery systems, that's changing a little bit, but there's still a lot that people have to actually do. They have to be the control engineers, whether amateur or expert.
That is a really good point. So there's two things there I want to parse out. First, you point out that the quick urgency of diabetes. I just had a sandwich. I ate lunch actually 2 hours ago. I'm thinking about, even while we are having this conversation, about what my blood sugar is now. Right now I'm at 170, which is high, but it's an hour after eating. So hopefully it'll be back down to 100 within an hour or so. And I'm trying to get back down softly. Like, I don't want to crash and have an awful afternoon, but I do want to get down quickly and comfortably so that I don't have an issue like you talked about. But then there's well, if I hit 180 every single day at lunchtime for 20 years, what kind of microvascular things might I deal with in 20 years? In the past, as you said, I have to look at the numbers and I have to make the decision. So in control engineering, you have a sensor, you have a detector, and you think about your output performance, and you kind of loop, don't you? You look at the number and you make a decision. But I don't know if everyone is good at that. That seems like a very unfair thing for a disease to make me have to be good at math.
Right. It takes a lot of math and that constant monitoring because most control systems have these time steps where they look and make decisions, and they're
Mm-hmm.
every 5 minutes, every 15 minutes, whatever they are, but it's very frequent. So
Mm-hmm.
you want to go out and live life and not worry about diabetes so much. So having to do all of that. Um, as a human, you're obviously going to have a much longer control interval, which will make your glycemic outcomes suffer. But there's always this trade off between glycemic outcomes, safety, and usability, or the ability to go live your life.
Mm-hmm. So when you think about a control system, it's like cruise control in a car, right? I mean, you're thinking about the speed and you're adjusting the motor as you go forward and backward. And I think that maybe basic self-driving cars that try to stay inside the lane are a kind of a control system, but they really are just focused on the moment, right? Do control systems think about the future? Do they think about days in advance or weeks in advance, or they only think about the now?
Well, there's definitely several components there. So you have a prediction component, and that's especially because of what one of the factors you mentioned. So insulin that's given exogenously is not the same as the insulin a healthy pancreas might produce. It
Mm.
takes a lot longer for it to start acting.
Hmm.
to start showing an effect on blood glucose, and also a very long time to leave your system compared to the glucose your pancreas might produce. Sorry, the insulin. Um, so because of that, you have to predict a lot more. If insulin was really fast and you could see its action immediately and it really went away quickly, then this would be a much easier problem. But because you have to predict and wait and measure everything that's already in your system and what will it do 3 4 hours from now, there's
Hmm.
definitely a big prediction component to it. And
Yeah.
then there's the adjustment when things are different from what you're expecting. How do you adjust the insulin levels? And then there's also the models and parameters underlying that. What is the effect of insulin on blood glucose? What's the effect of carbohydrates from meals on blood glucose? And those have parameters that are very specific to individuals.
Hmm. And then that word that you use that people who are listening may not be familiar with, exogenous insulin. That's insulin your body doesn't make. So you're saying that regular people, the normals, the normally sugared people, they have insulin that's coming from the inside of their body, while we're basically shoving insulin in, and we're using fat on the outside of our body to absorb that insulin, which is not really what fat is for, is it?
Right, right. So it creates different reactions from what you would see in a person without diabetes.
Mm-hmm. So when you're thinking about this in the context of data science, there's all these variables to think about. There's variables that you've identified and you've noticed and you've fed into your models, but then there's a lot of hidden variables. Like right now, I had my sandwich. My blood sugar is going up a little faster than I would have liked it to. I did everything right though. And the part that I find so surprising and frustrating about diabetes, and I wonder if you do as well, is it worked yesterday. Why doesn't it work today? How do you solve for hidden variables like that?
Right. Well, there's a lot going on, and Adam Brown actually published a list with 43 factors that are known so far that affect blood glucose levels,
Mm-hmm.
and some of them are the obvious ones we talked about, like carbs and insulin. But
Mm-hmm.
there's also stress, illness, all these variables that we can't accurately measure, and we could get more sensors and more data about exercise and other kinds of activities that would be helpful. But there
Mm-hmm.
will always be these hidden, unmeasured components that we need to address and respond to, which is why automatic insulin delivery systems are so important, because they take that burden from the user. So instead of um, tracking what happens for the next 1 2 3 4 hours after a bolus, you might
Mm-hmm.
rely on a system to automatically adjust to those unexpected changes or that unpredictability. And
Mm-hmm.
a good algorithm will have ways of dealing with those unmeasured disturbances. It's
Mm-hmm.
not going to work as well as if you could measure everything perfectly accurately and adjust for it mathematically, but there are ways to deal with the uncertainty statistically.
Yeah. We always have numbers in our heads that we know. Like I know my ratio of insulin to grams. And I'm sure that mine is different from yours. And we think about those things, but I'll make sure that we include a link to the 42 factors that affect blood glucose. Uh, it's all kinds of things you wouldn't think about, like sleep, too little sleep, or someone going through puberty or having bad allergies. And one of those is making my day different than it was yesterday. Who knows which one of them, or many of them, multiple factors that are causing me trouble today. That kind of requires a certain cognitive load, doesn't it? Don't you feel like there's a certain percentage of your brain that's always used up thinking about diabetes, even when you're not thinking about it?
Yep, I think mental burden is a big component of diabetes, and that there's that complexity. But like I mentioned before, I think it's there's a trade off between um, that effort, that level of effort you're willing to put into it or able to put into it, versus
Mm.
glycemic outcomes versus safety. And a lot of people who like to talk about diabetes in podcasts, or build their own gadgets, or are really involved in this and really mathematical, try to
Mm.
optimize for glycemic outcomes.
Hmm.
But there are also people who just don't care for all that complexity and just want to have diabetes fade in the background, even if that they don't get the absolute best time and range or best glycemic outcomes that they could.
Hmm. And again, for the context for the folks that are listening who may not be familiar, when we say things like time in range or glycemic outcomes, that's basically you and I trying to simulate that we don't have diabetes, right? Because isn't the theory that if we can get the body to have as normal sugar as possible as long as possible, then we'll die of something else. We'll die of old age as opposed to dying of a diabetic complication. We're simulating not having diabetes.
Right, right. So you want to stay within a narrow range and mimic healthy blood sugar levels as much as possible.
Hmm.
And with a lot of effort, you could do that pretty well. And with adjustments in your diet, you could also do that well, but it does take a lot of effort. And throughout people's lives, for example, for me, sometimes I put a lot of emphasis on glycemic outcomes, and
Hmm.
sometimes I said, okay, an estimated glucose value of that's a little higher is okay right now. During this time for my life, it's okay if my blood sugars are a little bit higher because I'm
Hmm.
trying to achieve all these other things.
Exactly. Because the stress is itself difficult. So run a little high and be more mentally healthy.
Right, or have bandwidth to do other things.
Yeah.
And I think if you're mathematically inclined, it's easy, but that's why new technology should relieve some of that burden. We should really be doing this math for people and helping people who don't want the absolute best clinical outcomes, but want to
Mm,
put in a lot less effort, get much better outcomes that they're getting today. Maybe not as good as someone who's constantly fiddling with their device and estimating and knowing about all these factors that the device doesn't know about, like exercise, stress, illness, trying to account for all of these,
right.
but really giving them the best outcomes they could have for their lifestyle.
Yeah, that's a really great point because I've been involved in the DIY, the do-it-yourself diabetes community since the '90s, and I think it's enjoyable, and I find the math interesting, and I find the tinkering interesting. But when I show it to other people, they're like, "Wow, that's just way more work than I really need." Even the finger sticks part people are losing patience with. And that's why it's exciting that there's new technology like the Dexcom G6 that does not necessarily require finger sticks. And of course, the company that you work for, Tandem, has a thing called Control IQ combined with the no finger sticks means that like a huge percentage of people find that to be much easier to use. They don't have to think about the math. They just are there. I don't know. It almost makes diabetes fade away for a moment, and they can kind of pretend that it's not happening, which is really healthy, I think.
Yep, it really allows people to go do the other things that are important to them and
Mm,
think about diabetes just a little bit less.
yeah,
And don't get me wrong, there's still a lot to think about. There's a lot that goes into an insulin pump and that goes
true.
into diabetes education just to get started using these devices. But we've come a long way, and I think it's a puzzle, not a mystery. We know how to do more.
I like that. That's a really great point. There is a lot of cognitive load, but it's just if you're going to become diabetic, certainly today in 2020 is the time to do it. No one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or a few API calls. MongoDB Atlas automates deployment, automates updates, handles scaling, and more so that you can focus on your application instead of taking care of your database. You can get started free at mongodb.com/atlas. Now, if you're already managing a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime and then get back to what matters. Stop managing your database and start using MongoDB Atlas. I'm curious, what kind of problems would a diabetes data scientist solve? Are you solving control loop, local, immediate problems? Are you thinking about huge data sets? Like I have a massive personal data set of my blood sugar every 5 minutes for the last decade. I don't know what even kind of questions I could ask that would make my life better. What kind of questions can a diabetes data scientist ask to make lives better?
Well, there are lots of such problems. I think data science is a very large term. It encompasses a lot of disciplines. And even though
Mm.
it's a recent term, there have been data scientists around for a while.
Mm-hmm.
So for diabetes, I think data scientist could build personalized algorithms for diabetes management, like
Mm-hmm.
the control algorithms we were talking about, or prediction algorithms to see where your blood glucose is headed, or what the
Mm-hmm.
effect of the inputs into your diabetes management are having.
Mm-hmm.
And then you can also use it to inform decisions and to make simpler products. So one of the things I get very excited about is how we can use big data from a lot of users to evaluate product features and feed those insights back into to product development. And
Hmm.
how could we use data and simulations to further simplify our products and make them easier for the user?
That's very interesting. I'm thinking about anonymized data across multiple people. Like, here's the blood sugar for 10,000 people. You're saying you can see how they would do on a new product?
Well, there are certainly things you could simulate, and as George Box says, all models are wrong. Some are useful. So it depends what you're trying to do, but there are definitely a lot of things you can evaluate, especially design trade-offs and things you could test and say, well, what are the differences between this choice or that choice?
Mm-hmm.
And then there are also a lot of knobs in the product. For example, one of the typical insulin pumps on the market today from the different pump companies has over 1,000 settable parameters that someone could go in and tweak manually.
Huh.
It's a lot. For example, for someone's physiology settings, you could set different values of three parameters every 30 minutes of the day, and those aren't the only examples. So some of those engaged users, like the ones in the do-it-yourself community, will spend their time analyzing their own data and
Mm-hmm.
really thinking about what they did that day, what's affecting their blood glucose levels, and turning these knobs to get the perfect outcomes.
Mm-hmm.
But people who are not mathematically inclined or don't want to put in as much effort into this, don't find it fun, really have to think about a lot. So, can we use data science to figure out how to remove some of those knobs for people who don't want to think about them, or how to set them by default so that they're better for the majority of the population, which ones are really important and which ones are not, things like that.
That is really interesting. Okay, so then back to the beginning of the conversation around all of the different factors that affect blood glucose, 40 plus that are identified, but potentially hundreds or thousands that are either not easily identified or not easily measured. You're saying that you can experiment, you can glean, you can assume, you can make smart decisions about those factors, thereby reducing the cognitive load for people who may not want to. But then you can also leave those knobs for those who want to click advanced and maybe go and dig into that stuff.
Exactly. Or you for those people who want to go and do more with it, you could provide the information and then they could decide what to do with it.
That is very interesting. The amount of little changes that I make, even now, 25, gosh, almost 30 years in, is experiments. It always feels like every day is an experiment. Like for example, I'm looking at my blood sugar now as it's starting to level off the blood sugar values that we were just talking about, and I'm realizing I should have taken my insulin 20 or 30 minutes before. That's an obvious first tip. It's something I should have thought about beforehand. But here's yet another day, another experiment where I'm like, oh shoot, now I'm kicking myself. I should have done that. I've learned that lesson. Why didn't I do that? You could potentially have software tell me that. You could remind me and nudge me in the right direction.
Yes, and I think different people find different things like that that are really helpful for them.
Hmm.
For me, for example, I was an MDI user for a while. I was waiting for this time when CGM would be accurate enough that the extra complexity of a pump or having it on my body would be worth it because I would
Hmm.
have all this data to make the pump do exactly what I wanted. And at that time, when I got on the pump, I thought CGM would be good. It wasn't actually that great. It had a really long lag for me. And I was getting low, feeling hypoglycemia, treating it, and maybe an hour later, I'd get the alarm. But because this exposed me to the pump, I could see the importance of having really good basal rates. And there are these guidelines for doing experiments to set your basal rates correctly.
Hmm.
And if you do those, it's a lot of effort. And most doctors or diabetes educators don't even tell their patients about it because most people would not go through all of that. That involves skipping a meal and just seeing is your blood sugar perfectly flat where you want it to be when you skip that meal. And tweaking your basal rate until you get that blood sugar to be perfectly flat when you're not eating or performing any kind of activity that affects blood sugar levels. But I found personally that when you do that, you're in this very stable state where you can make a lot of decisions easily, and your blood sugar is a lot less variable.
So, for folks who may not be familiar with those words, a bolus is an injection or a moment where a significant amount of insulin is introduced into your body, while basal is that little background insulin. Sometimes when I describe it to non-diabetics, I think about when you're driving the car and you're trying to keep the car straight on the freeway for a long period of time. You know how you just kind of jiggle the wheel a little bit just to stay in the. You don't even know you're doing it. You want to just stay straight. That's your basal. And then making a big left turn or a big right turn, that's your bolus. But what you just described, taking a day, fasting, not eating, doing an experiment on yourself as if you're a control subject, that requires a lot, asking a lot of anybody to do. But at the same time, if someone does do it, they should get some value out of it and really learn more about their body.
Yep, and it gives you a really good place to start from where you have to react to less. So I think
Mm.
about it as putting all this effort up front so that when you're out doing the things you want to be doing, you get
Hmm.
interrupted by diabetes less.
Yeah. It's interesting. I haven't done that in a while. I think it's been 4 or 5 years. That might be a thing that one would want to do every once in a while to just make sure nothing's changed, right? Because we get older, our weight fluctuates, our health fluctuates. It might be time for me to do that again. That's the other thing. You get used to your body and how it moves and how it works. So you're always having to reinvent your own diabetes therapy as you deal with this disease over a period of time.
Yeah, and if you make small changes, you could figure out when things are changing throughout. If you start with from a good place where your basal rates are working, you might make
Hmm.
smaller adjustments without having to fast in between to test this really accurately. But I think it's really important at the beginning,
Hmm.
and then just being aware of it and making adjustments when necessary.
How quickly do you think that the idea of an automated insulin dosing system is going to become like the standard of care? There's a lot of talk about them right now. They're available to those who can get the insurance, who can afford them. But do you think? I don't think it would be fair to say that it is the standard of care right now. It's kind of an emerging standard.
Yeah, I think automated insulin delivery systems are great. And like you were saying, people like us who have great insurance and have access to them, it really removes some of the burden and improves clinical outcomes.
Hmm.
It's great, but it's still not accessible to a lot of people. And
Yeah.
part of it is cost, part of it is, geography, the healthcare system. There are also complexity issues. Like with all technology, initially it's great for early adopters, and only through simplifying it and making it easier and easier to use, it becomes standard of care.
Hmm. And then, but even insulin pumps, to your point, you said that you used MDI, multiple daily injections, for a while. Even insulin pumps themselves aren't quite standard of care because of all the different reasons that you described. I wonder at some point, have you ever felt as a diabetic that your doctors, the people in power have told you that we'll have this cured in 5 years. I feel like for the last 20 or 30 years, they've been telling me just 5 more years and we'll have a solution. It feels like maybe from 5 years from now, automated insulin dosing will be the standard of care, and then there'll be another thing and another thing. Do you see an end to this, or what do you think the perfect answer is?
Well, that's interesting. No one's ever promised me a cure so far. I think obviously if we had a cure, it could all stop. But
Yeah.
so far, we've been addressing diabetes management, not the underlying causes.
Yeah.
So I think in that area, I think the first automated insulin delivery systems were built in there were two, and they were built in the 60s and 70s. So there was a portable one that someone was wearing with a backpack
Mm.
out there in the 60s, and I think it worked pretty well. And then there was one in the hospital system that was also working pretty well. It was very big system, definitely not portable.
Hmm.
So it took a really long time to actually have an actual portable wearable device.
Yeah.
And I think that kind of improvement, like the algorithm improvements came, there's a lot that we were able to achieve algorithmically, but there's also a lot left to do in terms of usability to make this work for everyone, to be able to just put it on and do nothing, which I
Hmm.
think is the holy grail of fully closed loop systems. Just put it on and it just works, and you don't have to know anything or do anything.
And you feel that that's a problem that we will solve with, to a large part, with software, with data science. Like, there is work to be done. We have not solved this yet. We haven't found the answer, but we will be able to, or at least we'll be able to move it forward a little bit every year.
I think we'll be able to move it forward. There's still a lot left to be done and a lot that we know how to solve. Humans will always have to be in the loop. It's your safety. You always have to change your devices, do a little maintenance, troubleshoot when things go wrong. But I think we can, there's still a lot to be done, and we know how to do a lot of it.
Hmm. Well, thank you so much, Dr. Alex Constantin, for chatting with me today.
Thank you very much for having me. It was fun.
This has been another episode of Hansel Minutes, and we'll see you again next week.